Ever wondered what would happen if you, well, farted in space? No? Well, someone has to ask the hard questions. Today, we're diving into a topic that's a little out there, but it's one that's certain to bring a smile to your face. It's a question you've probably never considered, but once you hear it, you can't help but be intrigued. How would a fart behave in the vacuum of space? Stick around if you're curious to find out how your rear end could impact the final frontier. Before we tackle the space part, we need to understand the science of farts. Yes, there's a science to it. Now let's not be shy about it. Farting is as natural as breathing. It's a normal byproduct of digestion. When we consume food, our bodies break down the nutrients, and during this process, gases like nitrogen, oxygen, carbon dioxide, hydrogen, and methane are produced. These gases need a way out, and that's where farting comes in. Imagine you're at a party, it's getting crowded, and the room is starting to feel stuffy. The party goers in this case are the gases. They're looking for an exit, and that's exactly what happens in your digestive system. The gases build up and eventually find their way out through the rectum. That, my friends, is the process of farting in a nutshell. Now, what makes a fart loud or silent, smelly or odorless? Well, that's all about the mix of gases and the pressure they're under. The more the pressure, the louder the fart. As for the smell, it's primarily due to sulfur-containing gases. The more sulfur, the stinkier the fart. Temperature also plays an interesting role here. Ever noticed how a fart feels warmer than the surrounding air? That's because the gases in our body are at body temperature, which is higher than the average room temperature. So, the science of farting is essentially a game of gases, pressure, and temperature. It's like a mini weather system in your gut. The gas buildup is like a storm brewing, the pressure is the force of the wind, and the temperature is, well, the temperature. When the conditions are just right, the storm unleashes in the form of a fart. Now, here's the million-dollar question. What happens when this storm, this fart, is released not in the cozy confines of Earth's atmosphere, but in the vast, cold vacuum of space? Now that we have the basics down, let's launch our fart into space. We've all seen astronauts float around in their spacecraft, but what happens when they let one rip? Let's plunge into the theoretical implications of this peculiar question. Now, the first thing to remember is that space is a vacuum, meaning it lacks air or atmosphere. This absence of air has a profound effect on how gas, like a fart, behaves. On Earth, when you pass gas, the surrounding air helps to disperse the fart, spreading its scent, so to speak. But in space, without air to push against, a fart would simply linger, creating a small cloud of gas that would stay put unless acted upon by another force. Next, let's consider movement. Newton's third law of motion states that for every action, there is an equal and opposite reaction. So, theoretically, if an astronaut were to pass gas in space, the force exerted could potentially propel them in the opposite direction. Imagine that. A natural, albeit smelly, form of propulsion. But how much force could a fart really generate? Well, the answer is not much. The average fart doesn't produce enough force to move a human body in a significant way. Still, in the microgravity of space, even a minuscule amount of force can initiate movement. Finally, we need to consider how the lack of gravity could influence gas dispersion. On Earth, gravity pulls denser, cooler air downward, allowing the lighter, warmer fart gas to rise. But in space, without gravity, the gas wouldn't rise or fall. Instead, it would form a spherical cloud around the astronaut, potentially leading to a rather unpleasant environment. So in theory, your fart could propel you forward. But that's not the entire story. The reality of farting in space is much more complex, and involves factors like the spacesuit's design and the spacecraft's ventilation system. But that's a topic for our next segment. Stay tuned and keep exploring the cosmos one fart at a time. But theory is one thing, what about the practicalities? What actually happens when an astronaut farts in space? Well, let's paint a picture. You're floating around, snug as a bug in your spacesuit, and then, it happens. You let one rip. In the confines of your suit, there's nowhere for that fart to go. It's trapped, like a ghost in a bottle. But don't worry, it's not all doom and gloom. You see, spacesuits are marvels of engineering, designed to handle such earthy realities. Spacesuits are equipped with a layer of charcoal to filter out odors, so your olfactory senses won't be assaulted by your own emissions. Besides, in the noiseless void of space, your little indiscretion will pass unheard. Silent but deadly indeed. Now let's shift the scene to the confines of a spacecraft. Unlike your spacesuit, a spacecraft is a shared space, and courtesy would dictate that you don't gas out your crewmates. Luckily, spacecraft are also designed with this in mind. They're outfitted with advanced air filtration systems that work tirelessly to keep the atmosphere inside the craft clean and breathable. These systems use activated charcoal filters, similar to those in your spacesuit, to absorb the odorous compounds in a fart. They also use lithium hydroxide canisters to absorb the carbon dioxide you exhale, and yes, the one you release when you fart. So while in theory, a fart could provide a tiny amount of propulsion, the reality is much less glamorous. The force exerted by a fart is so small that it wouldn't be enough to move an astronaut in space. Plus, your spacesuit and the spacecraft's air filtration systems would absorb and filter out the fart before it could make its escape. In conclusion, while farting in space may not be the most pleasant experience, it's not a cause for alarm. The systems in place are more than capable of handling it, so you won't be jetting off at warp speed, but your fellow astronauts might wish you were. So, farting in space isn't as explosive as we might have thought, but could it have other impacts on space travel? Indeed it could. The implications of flatulence in space extend beyond the simple release of gas. For astronauts on long-term missions, maintaining air quality is of utmost importance. The air inside a spacecraft is completely recycled, and any contaminant, be it a rogue fart or something more serious, can have an impact on this delicate system. Astronauts already have to contend with the smell of their own sweat and the constant odor of machinery. Adding the occasional bout of gas to the mix certainly doesn't help. There are filters in place to scrub the air clean, but they're not perfect, and can be overwhelmed if the situation gets out of hand. Health-wise, excessive flatulence can be a sign of digestive distress, something that would be particularly unwelcome on a long space voyage. And there's also the psychological aspect to consider. Living in close quarters with someone who has a bad case of gas could certainly strain relationships. On a more positive note, there's the potential for using the methane produced by farts as a resource. Methane is a potent greenhouse gas, but it's also a valuable fuel source. It's already used here on Earth to generate electricity, and it's one of the key components of rocket fuel. Could an astronaut's own gas be used to power their journey through the cosmos? It's a wild idea, but as we push the boundaries of space travel, every potential resource is worth considering. Of course, the practicalities of collecting and storing fart gas present their own set of challenges. But then again, overcoming challenges is what space travel is all about. So, while farting in space might not be the most glamorous topic, it's one that has real implications for our future among the stars. So, there you have it, the good, the bad, and the smelly of farting in space. It's been quite a journey, hasn't it? From the breezy start, we dove into the science of farts, exploring their composition and the physics behind how they work. What seemed like a simple everyday occurrence quickly turned into a fascinating exploration of biology and physics. Then, we delved into the theory of what happens when you pass gas in the vacuum of space. This took us down a path of understanding the effects of pressure differences, the absence of oxygen, and the potential propulsion power of a fart in zero gravity. It's not every day that you find out your own body can serve as a miniature rocket engine. We went on to discuss the practicalities, from the potential dangers of trapped gas in a spacesuit, to the implications for space travel hygiene. We realized that something as natural and hilarious as farting carries serious implications when it comes to the closed environments of spacecrafts. We brought it all home by discussing the impact on space travel. From the design of spacesuits to the dietary considerations for astronauts, the effects of this seemingly trivial act are far-reaching. Next time you let one rip, remember you're participating in a scientific process that reaches all the way to the stars. Stay curious, folks.